wabarakatuh. Welcome back to Mathematics class with me, Miss Ika Surtiani. In this pandemic time, I know that it is really hard for you and also for me, but hopefully this condition will not stop you to learn something new. And now we are going to learn new topic, which is standard normal distribution. There is something interesting about this topic because we can see the relationship between normal distribution and the spread of COVID-19. What kind of relationship is this? To know it more, now let's check it out.
Today we are going to discuss about the standard normal distribution. Okay, so before we discuss about the main material of this topic, I want to show you about this curve. Yeah, so recently this kind of curve is really familiar because it shows the spread of coronavirus. Yeah, these two types of curve actually are the same, but the difference is only about the time. So the horizontal here shows the time of the spread of the coronavirus, while the vertical line shows the number of cases. Okay, so in order to make the healthcare system can take care of everything or take care of all the patient, we need to make this curve lower than this. It means we have to make the spread of the coronavirus longer. How to make it longer? Yeah, so by doing the social distancing right now, by doing the learning at home like this right now, these activities are needed in order to make the spread of coronavirus longer, so our healthcare system can take care of everything. That's a little bit about the coronavirus. So that's why we need to stay at home and then avoid the crowd to make the spread of coronavirus longer, and then we can make the curve flatter than the first curve here. Okay, so what is the relationship between this curve, the spread of coronavirus curve, and our material today? So we are going to focus on the shape of the curve here. The shape of the curve. Yeah, the shape of the curve or the bell shape here is the shape of the normal distribution curve. Yeah, or we can say it as the bell shape, because most of the event or maybe activities or maybe the data in our real life are normally distributed, especially the data with the huge number of frequency. Yeah, because this curve for the spread of coronavirus, yeah, it's applied for a huge number of people. So yeah, that's why the spread of coronavirus or the graph of coronavirus spread can be represented as the normal distribution. Yeah. Okay, next. So we are going to discuss the characteristic of normal distribution curve. Yeah, so the first one, the shape of the normal distribution curve or the normal distribution graph is a bell shape, which is the peak is in the middle, and it's symmetrical, 50% on the left and then 50% on the right, while the mean, median, and the mode is in the middle, and the value of the mean, median, of the mode are equal. Yeah. Well, so we are going to focus on standard normal distribution. Yeah, for this meeting. So what is a standard normal distribution? So standard normal distribution is a normal distribution with the mean of 0 and standard deviation 1. Okay, the symbol of the normal distribution here, It's only the common, only any normal distribution symbol, not the standard one, but any normal distribution. This is represent that the x is normally distributed. The first number represent the mean, while the second number represent the variance. Okay, so the second one here, the standard normal distribution symbol, the standard. So the mean is 0 and the standard deviation is 1. In this case, the mean here, the first number is all represent the mean, so the mean is 0, while the second one is the variance, because the variance or the sigma square or the standard deviation square is 1. That means that the standard deviation is also 1. Yeah. Okay, so we are going to focus on only areas under the standard normal curve. So we are going to calculate the probability of the standard normal distributions that represent by using the curve, the area under a curve. Okay, so this picture is showing the probability of the standard normal distribution from 0 to z. Z is represent a certain number. It can be 1 maybe, or 2, or 1.2, or 1.3, or 2.5, and any kind of numbers. Yeah. Okay, to calculate this, don't worry, you don't need any formula, you don't need any calculator, because we are going to use the table. So the table is provided. The standard normal table is provided. So during your assessment event, the table is also provided. So don't worry, we don't need any formula, we don't need any calculator to do this. Yeah, so to make it clear, I will start with the example number 1. So the example number 1, if we are going to find the probability of z from 0 to 1.2, and the second one is finding the probability of z. Z here is represent the standard normal distribution from 0 to 1.26. Okay, the first step to solve this kind of problem is drawing the graph. The graph, it means that the normal distribution curve, the normal distribution graph, the bell-shaped graph, and then the second one, finding the value of the probability by using the table. Okay, the example number 1, let's draw the graph. Okay, here is the graph. The graph, the number is from 0 to 1.2. We are going to find the probability between 0 and 1.2. So please make the shade region between these two numbers. Okay, so the probability of z from 0 to 1.2 is 0.3849. So how do I get this number? Okay, from the table, of course. So where is the table, miss? Okay, I will show you the table. Oh, oops, sorry. Here is the table. So the table here shows the probability of z from 0 to a certain number. So we are going to find the probability of z from 0 to 1.2. Okay, look at this number on the left. So 1.2 is here. So now look at the number directly on the right side of 1.2. It is 0.3849. So the probability from 0 to of z from 0 to 1.2 is 0.3849. 3849. Okay, the same. Yeah, the second one is finding the probability of z from 0 to 1.26. The probability is 0.3962. Then, how do we read the table? Yeah, a little bit difference between the previous. The previous example, it is only 1.2, while the second example, it is 1.26. So, if it is a little bit different, then how do we get the number from the table? Okay, I will show you. Okay, sorry. Okay, so it only shows the number on the number in front of the decimal and then one decimal place. Okay, we are going to find 1.26. So the first thing, we spot this place 1.2, 1.2 first, and then after this go to the right and then look above 6. So this number is showing the probability of z from 0 to 1.26, which is 0.3962. Yeah, it's 3962. Okay, so got it? Yeah, 1.26. Go on the left, 1.2, and then go to the right, look at above 6. So this number is showing the probability of z from 0 to 1.26. Okay. Yeah. Now, how if it is negative? The example number 2, finding the probability of z from negative 1.5 to 0. Okay, remember that the shape of the curve or the normal distribution curve is symmetric. This table is only showing the positive number. We don't have negative number here. So, we need to change this into positive first. But don't worry, because this graph of the normal distribution is symmetric. So, the probability of z from negative 1.5 to 0, it will be equal to the probability of z from 0 to 1.5. The same here because it is symmetrically. Okay, so how do we get the number? Like this again, 1.5 directly because only has one decimal place. 4332, 0.4332. Yeah, it's done. Yeah, don't need any calculator, don't need any formula. Okay, next example. Okay, how do we find the probability of z from negative 1.2 to 0.65? Okay, don't forget to make the sketch of the graph. Okay, so it will be represent this, yeah, negative 1.2 to 0.65. Okay, we are going to split this into two parts because remember again that here it's always started from 0, which is in the middle. So if the region is spending on the two sides of this 0, so we need to split this into two parts. So this region, it's gonna be from negative 1.2 to 0 and from 0 to 0.65. Okay, so we can split this into two addition. So the probability of z from negative 1.2 to 0.65, it is equals to the probability of z from negative 1.2 to 0 plus the probability of z from 0 to 0.65. Remember that it will be equal to probability of z from 0 to 1.2. Remember the previous example. This one. Yeah, the example number 2. Okay. The previous example, yeah, it is symmetrically. Okay, x. Yeah, it will be the same. So how do we get this number? Remember, using this. If 1.2 here 1.2 ya, 1.2 3849, while from 0 to 0.65, 0.6, then 5, 0.2422, 2422, okay, and then add them together, you can find the value of this. Okay.
Okay, that's all for now, and hopefully this material can help you to understand about the standard normal distribution better and give you knowledge about the use of mathematics in our daily life. And wassalamualaikum warahmatullahi wabarakatuh. See you in the next video.